All right, I'm going to go over some of the answers for 6.1, page 437 through 438, the odds. Your answers are in your selected answers key. If you got any of them wrong, you can look through, and these are the ones that I worked out. So if you need to fast forward to the ones that you need to watch, please do so. And I'll show you the answers now. You can pause the video now so that you can check your answers on these. Number 15, I'll show the answer in my worked out solutions. Alright, for number 3 and 5, you didn't have to solve 5 times 5 times 5 times 5 times blah, 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 blah. You're just supposed to count how many there are. You know that the base is 5, and we have 1, 2, 3, 4, 5, 6 of them, so our exponent is 6. And again, this doesn't mean 5 times 6, this means 5 times 5 times 5 times 5 times 5 times 5. So 5 to the 6th power is the answer, and that's as far as you need to go. You didn't even have to solve them. So if you went through all that work, you did it for nothing. Now for number 5, same situation. We find the base, which is the number that's repeated. That's 27. And it's repeated 1, 2, 3, 4 times. So we have an exponent of 4. Again, it's not 27 times 4. It's 27 times 27 times 27 times 27. For number 7, I think this is the right one. Here we go. This is the right one. For number 7, we have 6 to the 4th power. And for this one, it said to write each power as a product of the same factor. So that means we need to do 6 times 6 times 6 times 6, and then find the value. So now we actually have to solve it out. The way that I've talked about in my previous video of doing it is that I would first multiply these two sets and say, okay, 36 times 36, and then I would multiply that out. You can do 6 times 6, which is 36, and then 36 times 6, and whatever that is, times 6 again. It doesn't really matter. It's multiplication, so the order doesn't matter. So I'm going to do 6 times 6 is 36. That's 18 plus 3 is 21. Put a little star here to indent. 18, carry the 1. 9 plus 1 is 10. Then add them all up. And so we get 1,296. Alright, number 9, same situation. It says to write it as a product with the same factor. So I'm going to rewrite it as 1/8 times 1/8. And then you're going to solve it. The way that we solve that is by multiplying numerator times numerator and denominator times denominator. So it's going to be 1 over 64. So your answer is 1/8 times 1/8. And then 1 over 64. Number 13. Number 13, we have the instructions say to find the value of each expression. So I've got 10.3 to the 3rd power plus 8. So I'm going to have to do 10.3 times 10.3 times 10.3 and then add 8 to that. So of course I'm going to do my multiplication first, because please excuse my dear Aunt Sally says I should. And so I'm going to start by doing 10.3 times 10.3. When I get that answer, I'll do that times 10.3. And when I get that answer, I'll add 8 to it. Okay, here's how I worked it out. I did 10.3 times 10.3, and I came up with 106.09. Then I took that number times 10.3 and I got 1,092.727. And when I'm adding 8 to that, I have to remember that 8 is a whole number 1. And so I had to line up my decimals and add 3 zeros after the 8. It doesn't change the fact that that's still 8. It just lines up my ones values. So when I add that all up, it's 1,100.727. Alright, so the answer for number 15 I haven't given you yet. It's one of my favorite problems on here because I feel like understanding when there's an exponent of 0 is like a complicated thing that people have a hard time with, so I wanted to be able to go over it myself with you. So the first thing it says is use the table to solve. Describe the pattern for the powers of 2. So we're going from 16 to 8, 8 to 4, and if you see the trend, the pattern is that we're dividing by 2. So if I do 4 divided by 2, I'm going to get 2. And if I do 2 divided by 2, I'm going to get 1. And so the values for 2 to the first power is 2, which makes sense. But the thing that everybody gets stuck on is that 2 to the 0 power is 1. And that's really something that is a complicated thing to explain, except to see this table and see how it works. Then for B, it says describe the pattern for the powers of 4. Okay, well, we're going from 256 to 64. What we're doing there is we're dividing by 4. And then we go from 64 to 16. We divide by 4 again. So going with that trend, I'm going to divide by 4 again, divide by 4 again, and I get 4 to the first power is 4, and 4 to the 0 power is 1. Now describe the pattern for the powers of 10. Write the powers of 10 to the first power and 10 to the 0 power in the table. So we start with 10,000. We divide by 10 and we get 1,000. We divide by 10 again and we get 100. We divide by 10 again and we get 10. We divide by 10 again and we get 1. So we're dividing by 10, and the power of 10 to the first power is 10, and 10 to the 0 power is 1. So write the rule for finding the value of any base with an exponent of 0. The rule is that it will be 1. And I know that's weird because a lot of us want to think that that's going to be 0, but if you see the pattern, it goes with it. Number 17 says, suppose the population of the United States is about 230 million. Is the number closer to 10 to the 7th power or 10 to the 8th power? Explain your reasoning. The first thing you need to understand is when we're dealing with tens, that exponent tells us how many zeros it's going to be. So when I have 10 to the 7th power and I have 7 zeros, I have 10 million. When I have 10 to the 8th power and I have 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8, I have 100 million. And so if we're talking about 230 million, what's closer, 10 million or 100 million? 100 million is closer. So that's the answer for number 17. If you have any more questions, make sure you're ready to ask them when you get back to class. See you then.